welcome to our second lesson on electronics. My name is Nicholas Okute. In the previous lesson, we learned different types of semiconductors, that is extrinsic and intrinsic semiconductors. Now, extrinsic semiconductors, which we said are further categorized into two, that is the P-type and the N-type. We want to dwell on those two. We start with the P-type semiconductor. Remember, we said extrinsic semiconductors are semiconductors whose electrical conductivity can be improved by addition of an impurity. An impurity can be a group 3 element, which we call trivalent, or a group 5 element, which we call a pentavalent. Let's look at the first type of extrinsic semiconductor, which we call P-type semiconductor. P-type semiconductor is a semiconductor whose electrical conductivity can be improved by doping with a group 3 element. A group 3 element, which we call trivalent atoms, e.g. boron. A group 3 element has 3 electrons in the outermost energy level. If it has 3 electrons in the outermost energy level, silicon needs 4 electrons to complete its outermost energy level. So it means the 3 electrons in the boron, it will be used in bonding, maybe with the first, the second, and the third, leaving one of the electrons not fully bonded. So what will happen? The absence of an electron, the fourth electron in boron, will make it do what we call kind of borrowing. That is, the absence will create something called a hole, and a hole is normally treated as a positive charge. So that extra or absence of an electron, which we call a hole, will now be responsible for the electrical conductivity here. Remember, now because silicon is having an electron there, it will try to attract an imaginary electron, meaning leaving there an absence of an electron, which we treat as a hole. So in a P-type semiconductor, the majority charge carrier become the hole. So the hole is the one responsible for electrical conductivity in this case. What about N-type semiconductor? N-type semiconductor is formed when we dope with a group 5 element, which we call pentavalent atom. Take any pentavalent atom, meaning an atom that has 5 electrons at the outermost energy level. So, because silicon needs 4 for bonding to complete its outermost energy level, 4 of the 5 electrons in the pentavalent atom will be used in bonding, leaving an extra electron. The extra electron will now be the one responsible for electrical conductivity in the N-type semiconductor. So we are having here electron as the majority charge carrier in a N-type semiconductor. So we are seeing the differences between the two types of semiconductors. P-type we dope with a group 3 and hole is the majority charge carrier. N-type we dope with a group 5 and electron become the majority charge carrier. Now when the P-type and the N-type semiconductors are connected together, they form a device that we call a p-n junction. In a p-n junction, we have the P side and we have the N side. The P side contains holes while the N side contains electrons. So the two can form what we call a p-n junction diode, which is simply a device that's able to allow electrons or charge to flow in one direction only. And charges normally flow from or can flow from the P side towards the N side. So p-n junction diode is simply a device, and we use it in most of the electrical devices when we want to restrict current to flow in a particular direction. So this is the symbol of a p-n junction diode. We have the P side, which is the anode, and the N side, which is the cathode. So in a p-n junction diode, there is a region around the P side and the N side, which we call the depletion layer. The section that divides the P side and the N side, we call it the junction. So when the P side and the N side are joined together like that, they form what we call the PN junction diode, with the depletion layer as the region towards the P side and towards the N side, and the junction, the middle part of it. Now, a PN junction diode, when connected to an external circuit or a source of power, like a battery or a cell, we form what's called biasing. So biasing is simply connecting a PN junction diode to an external source of power like a battery. And we have two types of biasing. We have forward biasing and reverse biasing. Forward biasing is whereby the P side of the diode is connected to the positive terminal and the N side connected to the negative terminal. In that case, current will be able to flow. And if maybe we connected a bulb, then the bulb will light. So these are just some of the symbols or circuit symbols that can be used to represent forward biasing. Positive terminal connected to P, negative terminal connected to N. Or simply here, positive terminal connected to P side, negative terminal connected to that. Or you can use the holes and the electrons. So hole being positive connected to P, and electrons being negative connected to the negative terminal of the cell or of the battery. What about reverse biasing? Reverse biasing is whereby the negative terminal is connected to the P side and the positive terminal connected to the N side. In that case, current will not flow, and if at all there was a bulb, then the bulb will not light. So these are just some of the symbols that can be used to represent reverse biasing. And you ensure that for reverse biasing, the negative terminal of a cell, the short one, is connected to the P side, and the positive terminal of the cell, the longer one, is connected to the N side. Being the symbols, those are just various ways of representing forward bias and reverse bias in a diode. So basically, we are supposed to know how to represent in circuit symbol the forward biasing and reverse biasing. We should also be able to know what we mean by P-type and N-type, distinguishing between the two, and finally how to present them symbolically. Now, for this PN junction, normally P simply means positive and N means negative. So like when we talk about P side is the side that has the holes, N side is the side that has the electrons, and they give it as a symbol PN, positive negative junction. That is the P side of a semiconductor connected or joined to the N side of a semiconductor, forming what we call a junction diode. Thank you, and that is the end of our lesson. Let's meet during our next lesson.